also is not the most general case, but this case is sufficient for us to understand. So we'll assume this chi is a matrix which is chi 1 1, 0 0, 0 chi 2 2, 0 0 0 chi 3. The most general thing will be this also will be non-zero. But let's understand, earlier we had the same element along the diagonals, only the velocity changes in the medium, it will be a transverse electromagnetic. But we will take a small change in this fashion. Now if I have this, now recall that equation which I have written there.
Can be always a 3/3?
Yes, because we are working in three-dimensional space. Okay, so its matrix dimension will depend upon space. So in three dimensions, it will be a 3 dimensions. So the equation which we will write down, that big equation which I have written down earlier, can be written in this form: k square 1 0 0 0 1 0 0 0 1 minus mu naught omega square into chi. This chi is chi 1 1 0 0 0 chi 2 2 0 0 chi 3 3. This term was made 0 last time, so we didn't have chi, or even if we had chi, it's only changing the epsilon. And finally, we have minus, I write the full K1, 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 K2, K1, K3, K2, K1, K2, 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 K3, K3, K1. Actually, I could have written this as K3. This entire thing operating on E0x, E0y, E0z is equal to 0, 0, 0. This is the equation. The last equation is this part of this equation is minus k dot of t. So you may verify that this is actually equal to this. For an arbitrary. Now earlier I chose that k is along z direction, but now I am saying k is k1 times x cap plus k2 times y cap plus k3 times z cap. So if I take that kind of an equation, then I will have a matrix of this.
So earlier we are having one term k square minus mu 0 omega square.
Yeah. That is here, right?
That is mu 0 omega square into chi.
Yeah. Chi is this.
So when chi is 0, we are having a one term k square minus mu 0 epsilon 0 omega square.
Oh, okay. So that is essentially I absorb that epsilon in this. So maybe I should write it like this. So let me write it in this. So you are right, what you said is correct. So I will write this as epsilon 1 1, epsilon 2 2, epsilon 3 3, where epsilon 1 1 is epsilon naught plus I1. Okay. Epsilon 2 2 is epsilon naught plus I2, and so on. So that is absorbed in that. I will make, we can make two simplifications. One simplification is we make two assumptions. Any physical problem, we have to make many assumptions to finally see the result. So first assumption is that I will assume that epsilon 11 is same as epsilon 22, but is different from epsilon 33. Okay, so slight difficulty compared to last problem. Last problem, all of them are equal. Then this is only one is unequal. And assumption 2 is I am going to assume this k to be in the xz plane for convenience. Okay, so k you can call it as, so imagine you have this is x and y and z. So I am choosing k in this xz plane. K in the xz plane such that if I choose this to be alpha or this to be alpha, then I have k as k times x cap into sine alpha plus y cap into cos alpha.
So that actually fixes the angle of incidence or something.
No, this is, as of now, it's the propagation. I don't have any angle of incidence brought in it.
Or just going through the field.
Going through the beam. Okay, so with these things, now I have, so what does it mean? This means that K1 is equal to K sine alpha, K2 is equal to, sorry, this is Z. K2 is equal to 0 and K3 is K cos alpha. So I substituted this equation. Wherever K2 is there, they will all become 0. This term will become 0. And I can write down this matrix is, so I will write down the final matrix with a little bit of algebra. You can show that this is k square cos square alpha minus mu naught omega epsilon 11 0 minus k square sine alpha cos alpha 0 k square minus mu naught omega square into epsilon 11 0 and minus k square sine alpha cos alpha 0 and k square sine square alpha minus mu naught omega square epsilon 3. This is the matrix. This under these two assumptions. I don't have epsilon 2. Epsilon 2 is same as epsilon 1 naught. That is one assumption, and sine alpha cos alpha. Because of the second assumption, I will get these 4 zeros. Okay, so this matrix into this E0x, E0y, E0z is equal to 0. Now, the determinant of this matrix, we have to ask it to be 0, and that gives you different constants. So let me say that if we ask the determinant of this to be equal to 0, then we will have the following conditions for this omega.